Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors 7-3 Extra Practice Number 3 solutions on parametric equations. This one we got a puzzle to do, so let's go ahead and check that out. So here's our puzzle. We're trying to solve the riddle, what do you call two equations that measure meters with respect to time, the horizontal and vertical distances traveled by an object in space? That sounds very complicated. What do we have down here? So this beginning stuff is kind of an introduction to parametrics in case you didn't really understand the concept behind them. The basic idea is you have x and y both being expressed as functions of t instead of being expressed in terms of each other, although you can rearrange it so that they are in terms of each other. So let's see here. Anything else crazy down here? Let's go straight to the problems. We have a bunch of problems to do, 1 through 21. And when we get the letter that goes with those problems, we're going to put it in the appropriate box down below, depending on what question number it is. Now, the one thing to realize is that there's two different sets of answers. So for 1 through 5, they're having you express y as a function of t and match one of these 5 answer choices. And now in these other problems here, you actually are doing kind of 2 problems for each of these sets of parametric equations and matching them with these answers down below, f through x. All right, so with that in mind, let's go ahead and see where this leads us. So here is our opening problem, number 1. We're given y equals 2x minus 1 and x equals t plus 1. And we have to express, again, the y function in terms of t rather than x. So the key here is we have to isolate x if it's not already isolated, which it is actually, and then just replace the x in the y equation with whatever x equals. So instead of writing 2x minus 1, I can write 2 parentheses t plus 1 minus 1. And then I just have to simplify to get one of these answer choices. So if I distribute this 2, I've got 2t plus 2 minus 1. And then 2 minus 1 is just 1. So we have y equals 2t plus 1 when the dust settles. That matches choice E, so I'm going to put that in box number 1 here. For this next set of parametric equations, just like before, I'm going to start by replacing the x in the y equation with whatever x equals. So I can write, instead of x here, I can write 2t minus 1. And then all I have to do is just add the negative 1 and the 2 together, giving me 2t plus 1. And then let's see here, that matches up with E again. There's another E. Now you might be thinking, wait a sec, didn't we just get E on the last one? We did, but they never said you couldn't use these more than once. So let's go ahead and put that in box number 2 right there. For number 3, this is actually going to be a pretty quick problem. If y equals x and x equals all this stuff, then y just equals t squared plus 1, just a direct substitution. No simplifying to do. This one is already done. So t squared plus 1 is right there. That's a. So put that in box number 3, which is going to be right over there. For this next one, we have y equals x plus 1. Since x equals t squared, I can just replace this x with t squared. And we have y equals t squared plus 1, which is a, which is, yes, what we had on the last problem. They're getting kind of fancy with us. So we're putting an A in box 4. So after those last 2 problems, you're thinking, well, this is actually pretty easy. This one's going to make you work a little bit more. So when we replace the x in this x squared with the t plus 1, we are going to have to, wait a sec, I was going to say we're going to have to expand this, but actually if you look at the answer choices before you just blindly do algebra, you'll notice we already have t plus 1 squared as an answer choice. So we don't have to expand this. We're just going to pick C and put that in spot 5. For the rest of the problems on this puzzle, we've got a different set of answer choices and different directions. This time around, they're giving us 2 questions at once. For the even numbered question, 6 in this case, they want you to rewrite these parametric equations so that t is a function of x. Then, for the odd number one, they want you to rewrite y as a function of x. And it'll turn out that doing it in this order, one thing will lend itself to the other. So let's do problem 6 first. So if I'm writing t as a function of x, I just have to isolate t in the x equation, which it's already isolated. So we just have t equals x. And the expression x is this f right here. So that's going in spot 6. So really not a whole lot going on with that one. For the next one, we need to write y as a function of x. You'll notice that all these y equations have a t in them. So whatever you just wrote for the t function, you're just going to substitute the x's back in to this y function. So instead of writing 3t plus 1, I'll write 3x plus 1. And having done that, there's no simplifying to do. So we're actually already done with this one. 3x plus 1 is choice R, so that's going in spot 7, which is over here. For question 8, writing t as a function of x in this equation, I can just subtract 1 from both sides. So we can write t equals x minus 1. X minus 1 is choice O down here, so that's going in spot 8. So we've got the word of in there. Next up, writing y as a function of x, I'm going to replace this t with x minus 1, so 3 parentheses x minus 1 plus 4. Distributing that 3, we have 3x minus 3 plus 4. And then negative 3 and 4 combines to give us a plus 1 there. So 3x plus 1 is r, which we actually did use earlier. This is now going in spot number 9, which is right here. There you go. For number 10, trying to isolate t in the x function, we're going to be dividing by 0.5, which essentially means if you're dividing by 1/2, you're really multiplying by 2. So we can write t equals 2x. And then replacing the t in the y equation, so wait a sec, 2x, let me get my answer choice here. That's t right there, so that's going in spot 10. And then if I plug 2x in for this t in the y equation for number 11 now, half of 2x is just x. So this is just x plus 1, which matches up with I going in spot 11 right here. For number 12, we've got some fractions going on here. Let's rewrite this x equation first to get t by itself. Now there's a few ways to do this. You could multiply both sides by t and then divide by x, or you could just take the reciprocal of both halves of the equation. Either way, you're going to end up with t equals 1 over x. And 1 over x is this s right here, so that's going in spot 12 at the very end. Next up, I'm going to replace the t in this y equation with 1 over x. So this is number 13 we're doing now. So we have 2 over 1 over x. If we multiply by the reciprocal, I'm really doing 2 times x over 1, or just 2x. That matches up with t, so that's going in spot 13 right here. For number 14, to get t by itself in the x equation, I have to take the cube root of both sides to undo a cube. So we have cube root of x. That's going to be right here, choice P. So that goes in spot 14. And then I'm going to replace this t in the y equation with cube root of x. So I've got cube root of x cubed plus 1. Now a cube root and a cube undo each other, so that's just x plus 1. And x plus 1 is this I right here, so that goes in 15 right over there. For 16, trying to isolate the x, or the t here, so I'm going to add 2 to the other side. That's going to be x plus 2 equals 2t. And then dividing both sides by 2. It looks like there's no big fraction sort of answers here, so I'm just going to divide each thing individually by 2. So we're going to have 1/2 x, or x over 2, plus 1, 2 divided by 2. So 1/2 x plus 1. The closest thing that matches is 0.5x plus 1. So that's q going in spot 16 right there. And then let me replace t with 1/2 x plus 1 over here for 17 now. So this is 2 times 1/2 x plus 1. minus 1 at the end. Don't want to forget about that. Distributing this 2 times 1/2 cancels, so you just have x for that first term. And then 2 times 1 is 2. Still have that negative 1 hanging around. 2 minus 1 is 1, so x plus 1 when the dust settles, giving me an I in 17. For 18, to get this t isolated, to undo a cube root, I have to cube both sides of the equation. So I can write t equals x cubed. And that's going to be an m right here going in spot 18. So we got metric going on, pair of metric. Okay. And then replacing the t with an x cubed in the y equation, that one's actually pretty quick because I just do the substitution and then it's already simplified. So x cubed plus 1 is going to give me an n in spot 19, which is over here. All right, we got one more pair of questions. To isolate the t in this first equation, just subtract 1. So we have x minus 1. X minus 1 corresponds with an O, so that goes in spot 20. And now replacing the t in this square root here with an x minus 1, I just have square root of x minus 1, which I can't really do anything else with. So that is the answer, and that's going to be a u going in spot 21. Now to solve the puzzle, what do you call two equations that measure meters with respect to time, the horizontal and vertical distances traveled by an object in space? You call them a pair of metric equations. Ah, there we go. Kind of like parametric. I see. All right, till next time, Mr. Sutton signing off.